Hello everyone, in this video we are going to use Jamovi in order to help us do a two-sample hypothesis test where we are comparing the proportions between two groups. Okay, let's take a look at our scenario. So it says that Ranger Gord is trying to figure out if he wants to go to the Bighorns or Snowies, mountain ranges in Wyoming, to hunt mule deer next season. He suspects that the proportion of hunters who see a 4-point buck or better is lower in the Bighorns than in the Snowies. If he can find significant results at the alpha level of 0.01, he will go to the range where more 4-point bucks were seen. Otherwise, he will go to the Bighorns as they are closer to his home. Ranger Gord somehow convinced Game and Fish to give him a list of hunters from the previous season. From this, he randomly selected hunters who were either in the Snowies or the Bighorns and asked them if during their hunt they saw 4-point buck or better. The data that he collected is provided below. All right, let's go ahead and gather our data and bring it over to Jamovi. Let's copy it in, paste it, and let's get some better labels. So this one we're just going to call mountain. And for this scenario, if we scroll down, we can see that group 1 is the Bighorns, group 2 is the Snowies. So we're going to leave group 1 or our top level as Bighorns, second level as Snowies, so that we are doing the correct analysis. And then over here, we're just going to call this like 4-point, and respondents either responded yes or no. And we want yes, typically yes, you want as your top level, but it kind of just depends upon what we are looking for. But we're interested in whether or not somebody saw this 4-point buck, so we're going to put yes at our top level. Okay, so now we've got our data in, and let's go ahead and answer our preliminary questions. So the type of data that we are dealing with here is categorical data, because we're dealing with these proportions. We're comparing the proportions between these two groups. So the method that we should be using is we are going to use a two-sample test for difference in proportions. Now, as we do this, there's actually two methods that we can go through and do it. If we do it by hand, which is a lot of time, a lot of kind of small computations that you do a z-test, but when we're using the software, it is much easier to just use chi-squared. And we'll be going into a lot more in depth in what the chi-squared actually is at the very end of class. But for right now, we can still just use the tool and just know that we are going to be using a chi-squared when we are doing these comparisons. So the population of interest here are going to be hunters in Wyoming who went to the Bighorns or the Snowies. And the grouping variable of interest is the mountain ranges. Which mountain range did these hunters, which one did they go to? And the response variable is whether or not they saw this 4-point buck. Okay, so the parameters that we wind up ultimately comparing between the two groups wind up being the true proportion who saw a 4-point buck, because that's what we are looking at. We're comparing these populations, hunters who went into the Bighorns, hunters who went into the Snowies, and we're comparing the true proportion of who saw a 4-point buck between the two groups. Oh, so this next question, we need to do a little contingency table to start seeing kind of what our data had. So we need to know, is our sample size sufficiently large to actually run this analysis? So we're going to use a shortcut, and it's actually not the best, and we'll get into why later. But let's go ahead and build a contingency table. We're going to put our mountain as our row, and we're going to do our 4-point as our column. Now, the shortcut method that we're using right now is we're just trying to see, do we have at least 15 yeses and 15 nos in both the Bighorns and in the Snowies? If we have any of them that drops below that, then we actually have a problem. However, it's actually not the correct way to do this. We really are supposed to be looking at expected values, and we will get into this deeper when we get into our chi-squared section. And it's actually not hard inside of Jamovi to give us. We can actually just tell it, give us our expected counts. And we really need to be looking for that. Are our expected counts in both of them good enough? But right now, we're going to use this kind of shorthand method of just looking at these sample sizes. And we're going to say that as long as we have 15 in each, we're going to be good. Okay, so we're said that we're good. Now, if we had selected no, that our sample size is too small, then we would need to go through and put all the way down here NA, because we shouldn't be doing our analysis. And it's important to know when we should stop doing the analysis. All right, so let's set up our null and our alternative hypothesis. So notice before this, hold on, so we saw that we had chosen like our distribution type. Our test that we're going to do is we're going to do this chi-squared right here. And so let's set up our null and our alternative hypothesis. So because we are dealing with proportions, the true proportion, remember, is that Greek symbol pi. So we have pi 1 minus pi 2 representing the true proportion of group 1 versus the true proportion of group 2. The null hypothesis is that they are equal to one another, that they're equal to 0. So that's our null hypothesis. Now the alternative hypothesis down here, what this one needs to be is it needs to mirror what our scenario set up. So here's our scenario. Our scenario says that he suspects that the proportion of hunters who see 4-point buck or better is lower in the bighorns than in the snowies. All right, so let's match up our null hypothesis now. So if we think that group 1, bighorns, is smaller than group 2, snowies, right here it's where it's stated, and we want that to be less than. All right, fantastic. When we do this, we need to make sure that we match Jamovi up with what our alternative hypothesis actually is, where we say that group 1 we think is actually smaller than 2. Okay, at this point, we need to also identify our alpha. So our alpha level, once again, we just scroll up to the top, and oops, a little bit too far. It's this alpha level of 0.01. And we can come back down. Alpha level 0.01. Now remember, alpha represents the rate at which we are going to make a type 1 error when we are going to reject the null hypothesis. Null hypothesis is actually true. So if we were to repeat this test over and over again, we would falsely reject the null hypothesis about 1% of the time, and we would reject the null hypothesis correctly like 99%. Okay, so let's go ahead and dive in. So our sample statistics that we want are the sample proportion of group 1 and the sample proportion of group 2. We can actually get this straight from Jamovi. Let's just go grab percentages in our rows, and it gives us the percentage of yeses in the bighorns and the percentages of yeses in the snowies. Just go ahead and type those in. 0.22148, and down here 0.54667. And our test statistic is going to be chi-squared, and it gives it to us right at the bottom. It's this 23.8475. And we can put in our p-value right over here, very small, 0.0001. And compare this p-value to alpha. It is less than alpha. Oh, great. So now that we've done this, we need to get our confidence interval where we think this true difference in proportions is. Well, we can give this that too. All we have to do is give us a difference in proportion, and we want 0.99. And since we've been working along the rows, we need to make sure that we are comparing rows. We can flip it if you want to compare columns, but that's not what we're doing right now. We are comparing these row values. Okay, and we'll hit enter. And we're given a lower and an upper. All right, so we've got a confidence interval of -1 and -0.16980. And our decision, because our p-value is less than this alpha, we are going to reject the null hypothesis. So our conclusion that we're interested in is that we have sufficient evidence. So we have, Ranger Gord has collected sufficient evidence. Chi-squared 1, which is just our degrees of freedom, and then our sample size n right there, and then our chi-squared test statistic, our p-value, which is essentially 1, and our alpha, to reject the claim that the true proportion who saw a 4-point buck of the bighorns is equivalent to that of the snowies, and instead conclude the true proportion who saw a 4-point buck of the bighorns is significantly less than the snowies. Ranger Gord is 99% confident that the true proportion who saw a buck of the bighorns is somewhere between 0.1698 and 1 less than that of the snowies. Based on this evidence, he decides to go to the snow. Okay, and there you go. That's how you do a 2-sample proportions test using Jamovi. Best of luck to you guys.